This lesson, we will be looking at the agricultural experiment example and how do we implement it into RStudio. So pretty much I'm going to show you how we got these results here. So let's go over to our R. First, we want to set our directory. Then we want to load in the farm data, convert our farm, fertilizer, and variety into factors. We're going to use this kind of structure. I put this so you have a general view on it to get our ANOVA table. So we're going to have our response, we're going to have our block. In this case, we had block. Let's say we didn't have a block and we had replicates, same idea. You would put replicates here, your interaction, and then this error term where you have block / your whole plot or replicate / your whole plot. We run this and we're going to get our summary. Let me make this a little bit bigger for you guys. And then you can see that we have our farm here. We have our whole plot for fertilizer with the expected mean squared here. And then we have our subplot factors or terms here. Okay. Again, all the different terms that we see. So we would be doing a test here for fertilizer, test for our variety subplot, and then the interaction. Again, in our case, variety and fertilizer were fixed effects. So you would want to test interaction prior to looking at the test of subplot and whole plot factors. Something that we might be interested in is doing a Tukey's analysis. This is a little bit different with subplots than what we've seen, so I kind of want to show you the code. You want to load this library. If you don't have it installed yet, you need to install it. As a reminder on how to install, you're going to go to Tools, Install Package, and you're going to type in the package name, and then press Install. I already have it installed, and I kind of don't want to waste video time doing that. So press Install. And then once it's installed, you have to call the library to say, I need those functions. All right, now we're going to do this. What this is doing is it's getting our data, and we're going to do the honestly significant difference, i.e. Tukey's. We're going to put in our response. You're then going to put in your factor that you're trying to see the difference in. And then you're going to put the degrees of freedom for the error and the degrees of freedom for, or your MS for your error. So where that's coming from is this right here for variety, because variety was in the subplot. All right. Then what this term right here is going to do is it's going to print to the console. So if I run this, it's going to output some stuff. But really what we're interested in is this right here, which is similar to what our jump users see. So if the letters were the same, that would say that the treatments are not different. Because we have group A, B, C, it's saying that all three of the varieties are different. Another way to do it, or the default, is that it has console equal to F, so it's not going to print. So if I was to, let me clear the console so you see that nothing's going to be printed out. If you do have that, all you have to do is out $groups, and it's going to produce the same thing. We could do a Tukey's test on fertilizer, and I mean you could. It wouldn't make sense because in fertilizer we only have two groups. So if we're saying there's a difference, we know the difference is between those two fertilizers. So it wouldn't make sense to do a Tukey's, but because it's automatically already kind of comparing those. With that, you now know how to implement a split plot design into RStudio.